Welcome back, everyone. In our last video, we learned about comments and how they're ignored by the C# compiler. Today, we'll explore the C# compiler itself, what it does, and how it converts your code into machine code. Here's the simple roadmap of how a C# code is converted to machine understandable code. First, you write a C# code and save it in a .cs file. Then, the C# compiler checks your code, and if everything is correct, it converts your C# code into IL code, also known as bytecode, and generates an executable file or a DLL file. After that, when you run your executable file, .NET runtime is loaded, and it converts all the IL code to machine understandable code. And finally, the machine understandable code is executed, and you see your results. Let's break each step down and understand it in detail. When you run the .NET run command, the compiler checks your code for basic errors, like missing semicolons. It then converts your C# code into a CPU-independent set of instructions called intermediate language, or IL code, and finally it generates an executable file or a DLL file with IL code emitted in it. Alright, let's talk about IL code, short for intermediate language, sometimes called MSIL or CIL. Think of IL as the universal recipe that sits between your C# code and the final machine instructions your CPU runs. Here's the quick rundown. C# compiler doesn't immediately spit out CPU-specific instructions. Instead, it emits IL code, a platform-agnostic, stack-based language that lives inside your executable and DLL. IL captures all the logic and structure of your program in a form that any .NET runtime on Windows, Linux, macOS can understand. IL code makes your code portable across all the devices which have .NET runtime installed. Let's revisit portability, why IL really matters. Think of IL binaries like a universal MP3 file. You rip a song once, save it as an MP3, and it plays perfectly on your phone, your car stereo, your laptop, no extra formatting needed. In the same way, when you compile to IL, you get one set of binaries that can run as is on Windows, Linux, or macOS as long as the .NET runtime is installed. No repeated builds, no platform-specific tweaks. You compile once, and your app just works everywhere. When you run your .NET application, the .NET runtime or Common Language Runtime (CLR) reads the IL code from the executable or the DLL file created by C# compiler. Then when the execution of code starts, the just-in-time compiler translates the IL code into native machine code specific to the current CPU architecture. The just-in-time compiler doesn't compile your entire application at once. Instead, it compiles methods as they're called for the first time during execution. This is the reason it is called just-in-time compiler, because it is compiling the IL code to machine code just before it executes a particular code. Once a method is compiled to machine code, the runtime catches this native code, so it doesn't need to be recompiled on subsequent calls. And the final step in the process is when the CPU executes the machine code generated by the just-in-time compiler. This machine code consists of low-level instructions specific to the processor architecture, like x86, x64, or ARM. Let's do a lightning-fast recap. You write your C# code, then compiler converts it into IL code, a cross-platform bytecode. When you run the app, CLR loads IL code. The runtime prepares your code. The just-in-time compiler translates IL code into native machine instructions. And finally, your CPU runs the optimized machine code. And that's the full pipeline from your editor to the CPU. See you in the next video.